Welcome to Session 7, Systems by Elimination and Substitution. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to select substitution or elimination based on visible structure, to scale entire equations without changing their solution set, and to interpret the ordered pair in the original context. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. A system solution is one ordered pair satisfying both relationships. The shared point is the target, not merely one coordinate. Elimination removes one coordinate temporarily. Back substitution restores the complete ordered pair. The key distinction is this. Select substitution or elimination based on visible structure. Then connect it to the second goal. Scale entire equations without changing their solution set. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Scan for an isolated variable or coefficients that can be made opposite. Identify the object being changed and the requested result. Step 2. If scaling, multiply every term in the selected equation. Use a separate line so signs, units, and restrictions stay visible. Step 3. Solve the 1 minus variable equation created by substitution or elimination. Work efficiently without skipping an operation. Step 4. Back minus substitute and verify the pair in both originals. Whenever possible, verify with evidence independent of the original working. Signal 1 is, a variable is already isolated. Respond by remembering. Use substitution. Name the response before calculating. Signal 2 is coefficients match or nearly match. In that case, use elimination. The form tells you which tool fits. Signal 3 is question asks for one coordinate. Remember, still verify with the full pair. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Solve 2x plus 3y equals 12 and x minus y equals 1. Restate the target and identify the most important part of the routine. The first move is, from the second equation, x equals y plus 1. This changes the form without changing the meaning. Next, substitute 2y plus 1 plus 3y equals 12, so 5y plus 2 equals 12. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Thus, y equals 2 and x equals 3. State what the transformed line tells you. Complete the argument. Check 2, 3, plus 3, 2, equals 12 and 3 minus 2 equals 1. This is part of the solution, not decoration. The final answer is 3, 2. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction. Substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. For x minus y equals 1, solve for x. Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. F-focused hint. Add y to both sides. Use it to repair your setup rather than guess. An accepted answer is x equals y plus 1. Explain why it works and name the first step that would expose a common error. The central message is, select substitution or elimination based on visible structure. Combine it with the discipline to scale entire equations without changing their solution set. Finish by remembering to interpret the ordered pair in the original context. This turns a calculated result into a justified answer. Reflection. Which visible feature made substitution faster than elimination? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 5 minutes, including verification in both equations. Keep the work readable, check it independently, and carry the routine forward.